After.
Right, online, you'll see now, you'll see in the simulation screen. Online, Anaya, Arissa, Emily, you'll see in the screen. Who can rely on here then? Or can pick somebody who other, no? Chris, you see in the screen? Don't we can have Chris. Yeah, okay. All right, so what you see? So how do we define or produce a wave, right? If you look here, there's a string. What's going on with this? Right. There's a string here, and there is no disturbance on the string. You're saying that? Absolutely no disturbance on the string. Right? So in order for us to produce a wave, what do we need to have? A disturbance, right? Yeah. So there must be some sort of disturbance here. And what that disturbance will do, it will cause the particles here to vibrate at different values. All right, so do I have to do it? Or?
Yeah.
Why can't we have the one? Have a next one to make it means that who's this? Right, so what you have there? So if you look there, what you're seeing is a wave being produced, right? And you will recognize that all the particles are what? Right? All the particles are basically moving up and down. You're seeing that? So if you look here, if I can pause this. Right, if I could pause this here, what we have here is a wave. Let's pull on, I want to show you all something. Anyway, might be able to see the particles move. Right, that can pass through. Right? What you will recognize here is that some of the particles are moving, right, all the time, while there are particular points that not really moving, right? It's not a perfect example. How to reduce down? All right, that pass. All right, so here we have particles that are vibrating, some vibrating to a maximum height, some not really vibrating and end up at zero, and some vibrating in between. As a result, we are producing a wave. Right, where is my pen? Right, here we have our wave. What you will recognize about most waves is that most waves transfer energy. So you might start producing energy here, and the energy is transferred all the way along. That's good? Right. Again, because of this energy being transferred, some of the particles, right, vibrate at different amplitudes. So here, this is the maximum, and we call this the maximum displacement. We call this our amplitude. That must be an A, right? You would recognize that this particle here vibrates, same thing, right? But a little bit smaller. We can probably see here the simulation. Not perfect, yeah? Sure. Because it uses some energy, right? But if you look here, all of these here are very similar, and we call those amplitudes. So your maximum displacement from this middle line here, we call that your amplitude. That's okay? Right, you might realize, kind of hard to count it now, but you might realize that this is technically a pattern repeating itself over and over. You see enough? Let's pretend it started here, right? Let's pretend it started here. Then you will see something like this. Then watch again. It will start back here, and you're going to see the same thing repeating itself. You're seeing that? So you have a cycle here and a cycle here. So this is called cycle 1, this is cycle 2. So from here all the way to the cross, that is your
You speak one voice.
Yeah. So that is called a cycle. You all okay with that? So this shape here represents one cycle. That's okay? And the time it takes, you kind of hard to see on this one, the time it takes for that cycle to be produced, we call that a period. Ignore that handwriting for now. That's the best I can do for now. And the number of these cycles in 1 second, we call it frequency. All right. Right? We call it frequency. I want to show you something here, right? If I were to, so there's this fancy word here called damping, right? I want you to picture damping as something taking energy away. Right? So let's say I would damp it. Let's say I wanted to do the same experiment. I wanted to do the same experiment in water. Let's just see what will happen. And I want to ask why after, right? Anybody recognize what happened there? Let's increase damping a little more. Anybody recognize what happened? What you can see happening there? Yeah? The amplitude getting smaller. Why? Because the particles don't have as much energy to vibrate. Okay? So damping is a process that kind of takes energy away from the system. You okay with that? All right. I want to show you 2 types of waves. Anybody know the 2 types of waves?
Yes.
Transverse and longitudinal. Nice. So what you see? Yeah. Oh, you're not me. Huh? Just want to show you this. Right, I used to have a slinky, but you wanna take it. Whoever you know, I thought it was me. What you say, right? Slinky, yeah, slinky now here. Right, for you, if you want to do any simulation in physics, right? Physics classroom, Java lab, and PHP can show you everything. So sometimes the problem with physics that we don't see certain concepts. You want to see it, you can try some of these simulations here, right? Right, where is the slinky? No slinky there? And that's up for them? No, but physics classroom has one. Yeah, but I know it's slinky yellow. Alright, watch this here. You're not seeing it, right? But watch this here, right? So that thing there's a slinky. You'll have a super that before? What's going to happen when they move it back and forth, right? Yeah. Yeah, move it quick now. Right. You're seeing that?
Yeah.
So what you're going to see is going to pause it when opposite. Wait, right. What you're seeing here, right? But you can see that in the back?
No. Oh.
You can see it in the back? You're seeing something moving, right? Right. If you recognize, if you look here, right, I will try to highlight it right here. Might be kind of hard to see. But if you look right there, right, all the little springs in this slinky extremely close together. And here it's a little bit further apart. You're seeing that? Right. So what we have here is a wave moving. In this case, it's moving this way. We have a wave moving in that direction. And the vibration, you probably can't see it so good, but the vibration happening in the same direction. So the particle vibrating left to right and it moving to the right. So these slinkies here, all the springs vibrating. And they're vibrating in the same direction it's moving in. Okay? Whenever that happens, that type of wave is what we call a longitudinal wave. Yeah. All right, so that's called a longitudinal wave, right? So the wave that you are seeing there is a longitudinal wave. Whenever the particles vibrate in the same direction, it's a longitudinal. Now, let's see if he's going to change it and produce a transverse wave. All right, so the next one now. Right, so he's gonna move up and down now and watch what will happen. Yeah, a little further. But if you were to move it up and down, here's what happening, right? That was a real bad video. Right? If you were to move it up and down like that, the wave's still going to move this way. But you recognize that it's vibrating up and down and it's moving to the right. Whenever that happens, that is called a transverse wave. I'll just put the first 5 letters, right? Transverse wave. Whenever the particles vibrate in the same direction, that is a longitudinal wave. Okay? Right? So again, it's not perfect, but that's how the slinky is supposed to work. Anybody ever slinky home? We'll bring it next, right? I take it back. Yeah, well, they have a mixture of grade, but they have less than 5. Yeah, let's bring it slinky to it. Sure, I'm probably back. All right, so nice. So head up waves, right? But this is not so spring. That's spring, right? Let's say here again. All right, so head up waves, please. So we're gonna focus on different types of waves and then learn about the features of all the waves. Right? Before I go to the official note, right? I was trying to draw something like this. So one of the waves looks something like this. Right? And I was trying to show you that from here to here, that's one cycle of the wave. That's okay? Here to here, that's the next cycle of the wave. Here to here, that's the next cycle of the wave. So here we have 3 cycles. Okay? And the time it takes for one of these cycles to be produced, we call that period. The distance from here to here, we call that amplitude. And the number of these cycles that we have in a second, we call that frequency. That's okay? And the wave moving, so therefore the wave should also have a speed. Right? And I'll show you how to get the speed of that wave. All right? Okay, so head up types of waves. Head up types of waves. Oscillation, similar thing. A particle moving from 0 displacement to maximum back to roll. Right, so there are 2 types of waves. Number one, progressive waves. Progressive waves. The movement of the wave,
What?
progressive waves, the movement of the wave, put in brackets vibration. The movement of the wave in brackets put vibration is confined in some small space. In some small space. Full stop. There are two types of progressive waves. There are two types of progressive waves. There are two types of progressive waves. Number one, a longitudinal wave. I'll spell it here for you. A longitudinal wave and a transverse wave. Huh? What? It has here. Right, the longitudinal wave, right, a small thing. For the longitudinal wave, the vibration. Oh, yeah, that's cool. Hello. Do you have the extra end? No. All right. Second? Okay. What I was saying there?
The vibration.
Right? The vibration is in the same. Is in the same direction to which it is traveling. The vibration is in the same direction to which it is traveling. So if you're traveling this way, longitudinal wave will look like this. There's a slinky diagram, right? So you will see that your particles are vibrating. The particles vibrating like this. So it's vibrating like this and it's moving to the right. That's okay? So they're vibrating left and right like this. And they're moving towards the right. This is the vibration of particles. So the particles vibrate in the same direction as the direction of travel. That's okay? And you have two main parts here and here. What do we call here? We call here compressions. I think he's called it that, Vishesh. Why do you think this called this compressions? Or the compress? So if you had a guess, what do you call this? Expansion. No, they don't call it that. Right? They call it reaction. That's a good guess. I don't like what people. Yeah, rarefaction. Rarefaction. So the ones where they far apart are rarefactions, where they're close together, we call them compressions. Okay, so here's an example of a longitudinal wave, and what's a real life example of this? What type of waves? Sound waves. So sound waves are longitudinal waves. Okay. And transverse wave and transverse waves. The particles vibrate perpendicular. Transverse wave. Particles vibrate perpendicular. Particles vibrate perpendicular to the direction of motion. As somebody said, yes, like light. Right? But again, slinky is some of the easiest way for us to see how the waves behave. Right? Transverse waves they vibrate perpendicular to the direction of travel.
Action of motion.
Motion. So if I were to give you a slinky and I said, okay, Kanisha, use this slinky to produce a transverse wave, this is what you'll end up with. And the way to do it is to move the slinky up and down. Okay? To move the slinky left and right, you'll produce a longitudinal wave. Right? Up and down, that will be the vibration of the particles. That's why it is good when you need class.
Hello?
Right. What do we call the high points? Crest. What do we call the low points? Oh, that one with almost spelling. Spell all right? See, like I spell everything wrong. So we have crest and we have troughs. So really and truly there are two types of waves, like progressive waves And these are the two examples of progressive waves. What's the next type of wave? Stationary. Copy it down. So these are crests and these are troughs. Any questions online? Next one. Finish. Simulation. I simulate for the I need to show you. Huh? And the second type of waves is called stationary wave. The second type of waves are called stationary waves. Right? Sometimes people call them standing waves. Stationary or standing waves. First up, in these waves, stationary. They can spell station. Right. Stationary or standing waves, the particles vibrate.
That's what we just said.
Huh?
That's what we just said.
In these waves, the particles vibrate. In these waves, the particles vibrate. But there is no net. There is no net transfer of energy from one point to the next. No net transfer of energy from one point to the next. Let me just explain how these waves behave, right? So if you remember this simulation, right, with the guy with the little slinky, and they were moving the slinky left and right, and you all saw something move here and then move back here, right? There now in this example, there's an actual transfer of energy from here to here. But standing waves, on the other hand, all that will happen is that the particles will vibrate and stay right there. So the particles not moving from here and transferring energy. All that happens is that the particles just moving like this. Right? I don't know if you all ever saw this simulation with, this small video, it'll be on TikTok sometimes, where the person has a camera inside the guitar. And when he plays the guitar, you see some waves moving. Right. Those waves are not transferring energy along the string. Right? Those waves are just staying right there and vibrating the air around it and producing the sound that you'll hear. That's okay? Those are called standing waves. So it's more like an image. Right? So there is no transfer of energy from one point to the next. So okay with that? So the wave just moving up and down, that's it. There's no energy being transferred from here to here. That's okay? And those type of waves are called standing waves. All right? Right, but our focus will be on these types of waves. Standing waves is what you will do in paper if you're like physics. All right, next subheading, wave parameter. Next subheading, wave parameter. Right, wave parameters. Wave parameters. For a wave, for a wave, the following parameters are important. For a wave, the following parameters are important. The following parameters are important. Right? Underneath that, I want you to draw these two graphs here. I'm giving you two types of graph. I'm giving you a graph of displacement versus time. And I'm giving you a next graph. And I want to ask, what's the difference between these two graphs? I'm giving you a displacement versus position graph. Right? Question. What's the difference between those two graphs? Yeah, Kenny? Yeah. One has time in it, and one has position. Right? So this one here tells you how, the displacement changing with time. That's okay? And this tells you how what? Displacement changing with the position of the graph. Okay? So this one gives you a kind of length on the y-axis. This gives you time on the x-axis. So we could read off two different things from this graph, right? Copy it down. Oh my God. Right, so watch here. I'll give you the definitions in a little while, right? But watch this here. From a graph like this, the maximum displacement, we call that amplitude. Same thing here. Maximum displacement, amplitude. Right? How long it takes for one of these cycles, we call that period. Capital T. Right? But remember, capital T is our time, right? Yeah? So if I were to read off this value here, will that give me period on a position graph? No. That'll give me something else. And what we call that something else is the wavelength. Wavelength is how long one cycle is. That's okay? Right? Also from here to here, that's the same value. We could also call that a wavelength. Everybody okay with that? So amplitude, maximum displacement, time for one cycle, period, length of one cycle, wavelength. Okay, I'll explain phase difference shortly, right? I want to go through these words. All right, so add them in. Amplitude, period, wavelength, then we'll do frequency and then speed. Leave a little space to write definition, right? Good. Yeah, that's the thing. Right, amplitude, maximum displacement, amplitude, amplitude, maximum displacement from equilibrium point, amplitude, maximum displacement from equilibrium point, period, sorry, period, amplitude, maximum displacement from equilibrium point. Period, time for one cycle, period, time for one cycle. Period, time for one cycle. wavelength, length of one cycle, wavelength, length of one cycle, length of one cycle, frequency, number of cycles in 1 second, frequency, frequency, number of cycles in 1 second, number of cycles in 1 second. Oh yeah. If I know what you say, if I know the period is time for one cycle is 10 seconds. How can I figure out the number of cycles in 1 second? So period is one cycle in 10 seconds. How can I figure out number of cycles in 1 second? Divide both sides by 10, correct? So, is there a formula for frequency? 1 over the period. 1 over the period. Yeah? First one, repeat this one. No, other ways. Maximum displacement. Maximum displacement from equilibrium position. Equilibrium is this line here. Yeah? Write this formula for frequency. Right, I need some help. I need a formula for speed of a wave. Anybody could tell me generally how to find speed? Speed is what? So speed is distance over time. That's it? Leave it like that. So question, Vishish, how long does it take for one cycle? What letter on the board? How long does it take for one cycle? Anyone you want? How long does it take for one cycle? What letter? You sure? All right. How far is that? How far it is? How far is it to travel that distance? Like how long is that you can travel? Here to here is a what? A period, which is one oscillation. But how long is this? How long is this? How long is a wave? Right, one wavelength. So the time it takes to travel one wavelength is what? T, right? So, can you all see there one line? All right, it's here. So lambda, I just rewriting this, right? It's lambda multiplied by 1 on T. And these two are the same thing? What is 1 on T? What does that mean? It means that the speed of a wave is the frequency of the wave by wavelength. That's okay? So the speed of a wave is the frequency of the wave by its wavelength. You okay with that? Sure? You can see that? So if I tell you how long a wave is, and we know how much cycles in a second, we can work out the speed, which is meters per second. All right? So speed of a wave is the frequency by wavelength. All right? I'm gonna just give you some numbers to play around with, and then I want to explain phase difference, right? That's some of the only tricky thing in this, right? What is phase difference? You see that on that one? Yeah. Everybody okay with that? Right. So from this graph here, let's see if we can find each one of these, right? So it's an example. Let me make the first one easy. What's wrong with this? Huh? Yeah, I think so. They say higher protein.
Yeah.
Alright, let's go. Let us start with Post Malone. Post Malone, start here from now. What is the amplitude? Look at the graph. What is the amplitude? 10 what? I gave you a
10 meters.
unit, right? 10 meters. Number 2, Tiana, what's the period? Yeah. For what? 4 milliseconds. Nice. I wanted to see if somebody say something else. M means what, Megan? Right? M is milliseconds, right? Which is the same as what? 4 by 10 to the minus 3. That's okay? Frequency. What is the frequency, Javi? Frequency is what? Right, 1 on 4 by 10 to the minus 3, which is? Calculator. How much is that? What? Calculator. Are you going to get on your head? Yours? You sure? Then might do one over that. So it should be what? Around. Take it over. Okay, that doesn't come with it. What you got? No, 1 on? No. It should be 250 hertz, right? That's okay? Yeah? Bye-bye. Okay, now. Oh, why are you not that much to work? What do I have in it? I have 1 over. Bye-bye. Wait, remember it's in denominator, so when I bring it up, it becomes positive. I didn't realize that. Are you okay with that? Next. What's the speed of the wave, Soraya? What's the speed of the wave? Yeah, wait, if you go and get that wrong. Right, so I'll make it easy for you, right, to find the wavelength. What's the wavelength, Pishish? There's a time graph, so we just discussed that 10 minutes ago. Highest find wavelength. Look across there. Highest find wavelength. Justin, help them there. Highest find wavelength. Like the formula here, sir. Perhaps box around it too, sir. Yes, B means speed, sir. Right, so it's F over, sorry, B over F. Because they're moving across here. So you're going to get 20 over 250. How much is that? 0.8. Right, 0.08. Everybody okay with that? Bye-bye. Sure. Copy that down. Number 2. Number 2. Copy that number 1. Number 2 is going to make it do the reverse.
Yes.
Last one, before I give you one more. Number 2. Number 2, I am going to give you some info and you have to sketch it out. Okay? Number 2, sketch the wave. Sketch the wave. One line, you're getting through. One. Look at one answer from one line. Right. Sketch the wave on a displacement time graph. Sketch the wave on a displacement time graph. Given the following information. Given the following information. Amplitude 5 meters. Speed 10 meters per second. And wavelength 2 meters. Catch that graph. What type of graph are you again? A displacement time graph. And wavelength. So use that information to see if you can sketch the graph. The shape does be perfect, but the values I want, right? I want the values. The shape does have to be perfect. They thought to be there. You don't need evidence.
You don't need. No need.
Yeah. Are you still there? Go faster. Level very good content food. Very good plan. For that one, I don't know. For that one, very good plan. That's not one. The very good time that they try to do is like this. On I can see. Right, yeah. So the largest value is what? 5, right? Smallest value -5. Nice. What do we need here? Period, right? But we can't get period. There's no period here. So what to do? What we can do? We can get the frequency, so we know V is equal to F lambda. So F is equal to V on lambda. V is 10, lambda is 2. So we get 5 hertz. Now, how do you get period? Period is what? 1 on F. So that's 1 on 5, so that is 0.2. So the value here is 0.2. That's okay? Yeah? We get it one. Right. So in order for us to catch this, we need amplitude, we need period. That's the two most important things. Okay? Last note and we done. Wait is plenty notes until it's like wait for now, right? Reflection. Right, last thing. Last thing I want you all to we need to learn about is something called phase difference. All right. So watch this here. Here we have three waves, right? Wave 1, wave A, wave B, oceans. Right? Here we have three waves, right? Wave A, wave B, and wave C. We need to understand a phenomenon called phase difference. Okay? So if we look at wave A and B, right? If we look at wave A and B, what we can say about A and B, you recognize everything happening at the same point in time. So whenever the crest and crest line up, trough and trough line up, trough and trough line up, crest and crest, sorry, crest and crest line up, trough and trough line up. When those things line up, those waves are said to be in phase. So A and B are in phase. That's okay? But look at these here. Look at these here. Crest meeting a what? Trough. Trough meeting a crest. These waves, B and C, are out of phase. Right? So you have to learn two types of phases. In phase, out of phase. This is in, this is out. That's okay? To be exact, the outer phase by 180 degrees. Okay? And we have 20 different phase difference, right? Just imagine I could shift this wave a little bit to the right. And more to the right and so on. If I keep shifting this wave, as compared to this wave, you'll end up with different phase difference values. But at this level, you have to understand two. When the waves are identical, perfectly in phase, and when the waves are totally out of phase. Right? Crest and crest, in phase. Crest and trough lining up, out of phase. You okay with that? Right? And of course, there's a lot in between, in and out, right? But for now, you don't have to learn that. You just have to understand in phase, out of phase. All right? So that is your introduction into waves. Okay? So today we learned about these things of waves, the wave, different types of waves, and we learned the wave parameter. Next day, we're going to learn the things that waves undergo. Anybody remember the four things waves undergo? Reflection, refraction, diffraction, and interference. So we're going to do those four things. Walk with us. Come first, please. Next class. Walk with that foot track and compass.